I want to go back to conservative because that's like sibling crap there.
So one more example about chain rule before we move on, just to help you out with this.
Don't forget to record, Professor.
I am, thank you. Am I? Yes, thank you.
Your only job is to see it.
So, seems like some of you stuck. You should be good at this, not only because we're gonna test it, but because this is kind of the whole heart of this class. Learning to differentiate in 3D. That's exactly what I was telling you in Calculus 1 and 2 and 3. Learning how to differentiate is literally the main job of any STEM person. So either you do it or switch your major. Or like, why you're here if you don't want to learn how to differentiate? It's literally what you're supposed to do. So, equals 7. They ask you to find the partial derivatives. Find, and this is very nice exam question. Anything I ask you, any kind of partial derivative, you're supposed to be able to just do it fast and correct.
Just do it.
Just do it. Exactly. So why I'm saying any partial derivative, I could ask to find with respect to x, x, second partial derivative. With respect to yx. And maybe x depends on t and u, and with respect to t and u, and so on. So something like that. Now, we mentioned. Okay, let's do this. This is the notation I want to show you. Okay, fine. The idea is that you can keep the notes like this. It's okay. But the idea is we don't call it a function first. We just tell you this is a surface or a curve, and it looks like so. And you need not to freak out and create a name function out of it. We call it f. Okay, I see 3 variables, x, y, and z. And then to put this equal sign, what should I do? Move 7 to the left. X cubed z to the 8 plus sine 8 to the 6 z to the 8 minus 7 equals to 0. That's so without equals to 0, this is the name of the function. Then I can put equals to 0. It's kind of debatable, but okay. So you have to do it yourself, actually. We do it for you only a couple times, and then you have to do it yourself. Move everything to the left, and that's how you create f. F. F, capital F, is a notation of a surface or a curve. Depends on the dimension. Now, I did not cover in class because I don't really like putting this on the tests, but there is a shortcut for implicit differentiation. Technically speaking, you're supposed to do implicit differentiation right now because x is not written explicitly, or z equals is not written explicitly to find derivative with respect to x. So, implicit differentiation will work, but there is a shortcut for implicit differentiation. Capital F, taking a derivative with respect to x, so you see whatever was at the bottom goes to the top, over capital F with respect to z, whatever was in the numerator goes to the denominator, and then a negative sign in front because you kind of flipped. There's a theory I'm proving it, but it comes from implicit differentiation. It's a shortcut. Shortcut of implicit differentiation. I did not cover it because instructors like putting this on the test, and I remember I put it as well once, and people don't do it well. There are way too many things to mess up because you freak out during the exam. Either you do the wrong order, or you forget the negative sign. And then grading is really hard, so I don't think I will put it there unless it's very pushed by the department. So, negative is just part of the formula, huge fraction. The top is a derivative of this piece, including with 7. Don't forget that. With respect to x. Your brain thinks about this. Okay, x is the only variable here, and then there's nothing inside of x, so everything is looking good. Derivative of x cubed z to the 8 is 3x squared times z to the 8. Agree? I would color code the parts I'm actually differentiating, and whatever I'm copying it. What is derivative of sine y to the 6 z to the 8 with respect to x?
Cosine y to the 6.
Nope.
Sine y to the 6.
Nope.
0.
0. That's why it's so fun, okay? all those jokes like I'm gonna differentiate you, or I'm not afraid of you, but with respect to what? If I'm differentiating all of this with respect to gamma, all of this is 0. So it's like you are an important person depending on how I'm seeing you, for what kind of angle, right? So like this is exactly the same thing. This function is important with respect to x or z or y. With respect to gamma, theta, phi, there's some kind of constant. And that's kind of pretty cool psychological thing to see. Minus 0 because it's 7. With respect to z, your brain now have to see the z part as important. So I'm copying x cubed. Z to the 8 is 8. Z to the 7. What happens with sine y to the 6, z to the 8? Now I can see it's there. It is there inside. So that's chain rule. Derivative of sine, just like you said, is cosine. Copy the part inside. That's calculus 1. Copying everything, cannot touch it. Times chain rule starts here. That's one-dimensional chain rule. Derivative of the function inside with respect to, again, every time now you have to say it loud. With respect to what? With respect to z. So it's going to be y to the 6 times 8z to the 7 minus 0 because of the 7. Does it make sense? And that is the answer. Kinda, you can type it in without zeros. Don't type zeros, that's weird. But makes sense.
We get knocked off if we add zeros.
No, not with web work and not with my exams. I don't mind. It looks very weird to me, but why not? Sometimes I draw like a funny face if I see it.
You could add a lot of zeros.
You have a lot of extra time on the test, I guess. That will be time consuming. Then the formula for this one also will be like so. Minus derivative with respect to y. So you always exchange top with the bottom. Derivative with respect to z because z was at the top. Then you repeat the whole process. The good part is that some things you already found. The denominator is the same. Okay, so we don't have to do that. That is convenient. Because implicit differentiation have some kind of same parts. But with respect to y, now you take derivative of function f with respect to y. What is x cubed z to the 8? 0. There's no y there. Sine has y inside, so it's chain rule again. Plus, sine gives you cosine. Copy the function inside. Times, chain rule says, now look inside and see that y is a variable. Z is a constant. Derivative of that is 6y to the 5 to the 5 times z to the 8 minus 0. And this is the answer.
I think you forgot the negative sign.
Negative sign.
At the front.
Oh, thank you. The negative sign or sign, I was thinking which one you mean. Negative, negative, yeah.
Professor, can you do like implicit differentiation for one of them just so we know how to solve it that way?
I did implicit differentiation. Oh no, that will take forever. I did the implicit differentiation as example before. So, okay. Good question. You know, it's a smart question. Check yourself. Check that implicit differentiation will work. Implicit differentiation works. Hello. Works. You know how Russians say allo? Allo? And we also like really aggressive kind of way. I don't know why. Allo? Что? Что? No, my mom actually has a polite voice. She's like, слушаю. Which means like listening. I'm listening. Слушаю. And I'm always picking up like, allo. Anyway, implicit differentiation, when you differentiate everything without caring what it is, and then you're solving it for the right derivative, remember, and so on. So, but you need to remember that x depends on z, so z depends on x, and so on. Works as well. So, okay, so this, I will start, and then you will see what I mean. This will be implicit differentiation. With respect to x, you check what I'm doing. 3x squared times, but now z, right? Yeah?
Can you do it with respect to y? I think it's going to be more complicated.
But I don't want to do any. I want to move on to the next chapter.
Alright, forget I asked.
Okay, with respect to y, fine. They were differentiating with respect to y. X cubed now is a constant. Z is a function that depends on y. So you have to differentiate both z and y as functions. 8z to the 7 times dz with respect to y. And you will have to solve for this at some point, right? Check if I'm doing right. Plus derivative of sine is cosine. Copy things inside. Times derivative of the function inside. Y and z are both variables, so now it's a product rule. That's why I did not want to do that. 6y to the 5. Y is the independent variable, so there is no y prime here. Times z to the 8 plus y to the 6. So I'm differentiating this part as a product rule. Y to the 6, but then z now is chain rule. 8z to the 7 times dz with respect to y, because z depends on y. Well, not only y, but in this case, only y. Then minus 0 equals to 0. And then what we did in class, we were solving for this. How do you do that? Distribute, move all the pieces that involve this part to the left. Don't forget to distribute though. Factor out, and at some point you will have dz, so work over here, right? Like there's lots of work. And then dz over dy will be whatever is on the right hand side, some kind of like stuff with no derivatives there, over the factor out part that used to be attached to the dz over dy, which is this part, and this part. So some people actually figure out how to do it fast. And the answer should be the same.
If we know how to solve for that, can we?
Yeah, sure.
Jacob, you're such a mad lad.
What?
Will you be testing that for the exam?
So I will see what they give us as the coordinators, but usually some of this goes to the exam. About the minus f over f, I like to ask before the exam week of students, did you guys get it? And if the majority says no, I don't put it on the test. Because this formula is not that important. Internationally, it's not well known. It exists. People don't remember it usually, and that's why I don't big fan of testing it. But implicit differentiation is known everywhere, so that at least is good. We'll see. So, gradient. I forgot to tell you guys to watch the video, but you should, because the topics starting today are gonna be hard.
Yeah.
Are they gonna be? Who said? Oh my gosh.